This is Performance Time, the show about the human side of performance engineering. I'm Stephen Townsend. Okay, so as I mentioned, my name is Stephen Townsend. I am a performance specialist based in Auckland in New Zealand. I've been doing performance engineering and performance testing for the last 10 years, and the majority of that time I worked for consulting companies where I got a lot of exposure to different industries, organizations, peoples, tools, processes, technologies. I think that was really informative in terms of the way I think about performance. I currently work for an insurance organization called IAG. I've been there for just over 2 years now. And I guess my take on performance engineering is that, I'm not the smartest and I don't know the most. I am passionate about performance engineering and performance testing, and especially getting the basics right. I've always been really keen on that. But what this podcast is really about is the messiness and complexity of the real world and how we as human beings solve that. I think that's where I learn the most. It's the most interesting to me. I don't think we talk about the mistakes that we make or the things that we find really hard as performance engineers enough. And there's a huge amount that we can learn from that. So that's what this podcast is all about. Today's episode is all about some challenges I recently faced relating to performance testing a containerized solution. The application I was testing was a Java application, so not microservices, but essentially a monolithic application, which just happened to be running in containers. The infrastructure was built in AWS on EC2 instances. So each host was an EC2 instance, and each EC2 instance contained 2 pods, and these were managed by Kubernetes and Rancher. So that's the solution. Let's talk about the problems I faced. One of the things we noticed pretty early on is that the CPU usage on the pods was occasionally exceeding 100%. And when that happened, it didn't necessarily mean that application performance was degrading either. This came down not so much to the container infrastructure, but to AWS. You see, some EC2 instances are advertised as having, say, 8 CPU cores. But what they actually have is 4 CPU cores and hyperthreading enabled. So you have 8 logical CPU cores, but there's actually only 4, in air quotes, physical cores under the covers. So that was causing the reporting of percentage CPU usage to be out of whack. So our simple solution for this was to disable hyperthreading on our EC2 instances, which we found actually improved the performance of the application as well. The second issue that we came across is pretty similar, it's related. So sometimes we were finding that the percentage CPU usage was still really high on the pods, but the application performance and the user or customer experience was not degraded at all. So we were finding that average or percentage CPU usage on a pod was not a very good metric of the utilization of those containers or pods. And I remembered something that I learned in February this year at the Neotis PAC conference, which was in Greece, just before the whole COVID lockdown happened. And there was a speaker there, Eduardo Veroni, I hope I said his name correctly. He did a talk called Seeing is Knowing, Measuring CPU Throttling in Containerized Environments. And his talk was fantastic, and he explained with data to back it up that percentage throttle time is a much better metric for measuring how utilized a container is than percentage CPU usage, which we would tend to use on a physical server. So on my monitoring dashboard, which has a number of different views, percentage throttle time is front and center, and I use it as an accurate way to tell me whether the pods are overloaded. So in our particular case, when the percentage throttle time gets to between 5 and 10%, That's when we know that the application performance is being impacted and we need to notify someone. We set up alerts for both production and non-production environments. Whenever we go beyond 10% throttle time, we have to do something about it. I found it very satisfying to have this idea which I'd learned at a conference and then see it applied in the real world in a way which was providing so much value. If you take just one thing away from this episode, it would be, if you have a containerized platform, make sure you're monitoring percentage throttle time. And don't trust percentage CPU usage. It cuts both ways. On the one hand, your percentage CPU usage might be really high, but your application performance is actually fine. Or your percentage CPU usage could be really low, but there could actually be throttling happening and your users and your customers are suffering. Okay, the third issue is a sort of more complicated, messy real-world problem, the kind of stuff that I set up this podcast to talk about in the first place. So we're running these performance tests, and the application is running on 3 different pods. And normally the load is about 20% CPU usage reported by that metric, and there's pretty much no throttling, so that's good. But now and again, one of the pods suddenly uses 100% CPU or more, and there's a bunch of throttling happening. And this happens for 5 minutes. And this occurred again and again and again. And the more load that was being applied, the more often it would happen. And I had no idea what was going on. I reported it a couple of times, but at that time, there were bigger fish to fry. There were some other issues that we were trying to focus on. And eventually, I got some people who really knew Kubernetes and containerized platforms really well to be monitoring the platform live while I was running a performance test. And one of the guys noticed that during my performance test, there had been 37 pod restarts. And they looked into why that was, and there was an out-of-memory error. So there'd been a threshold set up to say each pod is only allowed 4 gig of memory, and if it tries to exceed that 4 gig allocation, then we need to kill the pod. Each pod had 1 JVM on it, and each JVM had been allocated 3.5 gigs of memory. And that left 500 megabytes for everything else, including Java non-heap memory. So the heap is the normal memory that we use in Java. So we allocate using configuration when we start it, say, in this case, 3.5 gigs of memory. That's what can be used by this Java application. But Java needs a little bit more memory on top of that to maintain the JVM. And that's what non-heap memory is. So in this particular case, Java non-heap memory plus additional memory used for other things was exceeding that 500 megabytes that was allocated to it. So that meant that overall, the pod had to request more than 4 gig of memory, which was the maximum that it was allowed to take. And when that happened, we'd configured Kubernetes to kill the pod, which was causing all of our problems. So the solution was to increase the amount of non-heap memory on each pod. Initially, we increased it to 2 gig. Then we brought it back down to 1 gig after proving that that was still stable. Full transparency, I was the performance tester here. I was observing the CPU pattern, but I didn't diagnose the issue. I needed an expert, someone who really knew Kubernetes and how containers work. But if I do see that pattern again, where the CPU is spiking up to 100% for 5 minutes at a time on a container or a pod, this is an avenue I can now look at. So that's all from this episode of Performance Time. Hope you enjoyed it. We'll be back next time with more performance engineering in the real world. Thanks again to Eduardo Veroni for his awesome talk on understanding container CPU utilization.